Okay, what is the impulse response of the system? Just consider a system. And if this system, the input to the system is, say, x of t, and the output is y of t, well, we can find the impulse response of the system if we assume that the input is delta t, because if the input is delta t, then the output is labeled by h of t, which is impulse response. This is actually impulse signal, and this is the response of the system to the impulse. But we don't have these things here. We don't know what is xt, we don't know what is yt. What we have is the input-output relationship of the system in differential equations. So for that case, then we should find what is Laplace transform of x of t. And we should also find what is the Laplace transform of yt. Because if we know this, then we can find the transfer function of this system. Because this equals y of s divided by x of s. And if we know this, then we can find h of t just by taking the inverse Laplace transform of h of s. Okay, so that's what should we do. That's what we have to find. Actually, that's the process we should do. We first should find this h of s, this transfer function, and then when we got that, we should find h of t by just taking the inverse Laplace transform over h of s. Okay, let's go ahead. Well, few things we should know. And that's let me write it here. Let me write it. Yeah, the same color is fine. Okay, so just assume that for a signal xt, its Laplace transform is capital X of s. Okay, so if I take differential derivative of xt, and then we are interested in the Laplace transform of this derivative of x of t, then that equals s times x of s, given that the initial zero initial condition, because this is actually minus x of 0, and if we assume that this is already given, then we can assume this is 0, and we can totally take this out. Right. And we can also say that second order derivative of xt equals s squared x of s, given that the zero initial condition. Okay, so bear that in mind. Now we should find the ys over xs relationship given this input-output relationship of the system. Okay. All right. So if I follow that, then we would have s squared y of s for this plus 2 times s times y of s plus 2 times y of s equals, well, I'm writing the corresponding Laplace transform of each part. And for this one, we would have s x of s plus x of s. Okay. Now I should try to isolate ys in the left side and x of s in the right side. So I would have ys times s squared plus 2s plus 2 equals x of s times s plus 1. Okay, so based on this, I can write the relationship, the ratio of ys over x of s equals s plus 1 over s squared plus 2s plus 2. Okay, let me write the rest here. So we have h of s, because this ratio is actually h of s. Okay, so h of s equals s plus 1 over, now I can write this polynomial here as s squared plus 2s plus 1 plus 1. Okay, instead of 2 I wrote 1 plus 1, and this equals s plus 1 squared plus 1. Okay, so we have s plus 1 squared plus 1. This is h of s. And if I want to find h of t, I have to take the inverse Laplace of h of s, or inverse Laplace of s plus 1 over s plus 1 squared plus 1. Okay, I have to take the inverse Laplace transform of this. If I check the Laplace transform table here, yes, exactly, this one is pretty much similar to what I'm gonna take the Laplace, the inverse Laplace transform. What is that? It says, let me write it here in different color. It says if we have s plus a over s plus a squared plus, say, b or omega or whatever, this equals, yes, it is omega squared. Okay, so this is omega squared. Then we can say the Laplace transform of this, let me write it in this way. The Laplace transform, the inverse Laplace transform of this equals e to the power of minus at times cosine of omega 0t times ut. Okay, so if you check here, if I take a equals 1, I would exactly something like this. Okay, for a equals 1. And then if I just replace a by 1 here, and omega 0 also 1, this is omega 0, omega 0 by 1, we will exactly see the same the same expression here. So its inverse Laplace transform can be then found by replacing a and omega 0 by 1 here. So the Laplace transform of this, the inverse Laplace transform of this equals e to the power of minus 1 times t, that is minus t, times cosine of omega t, which is 1 times t, u of t. So that's the answer for this question.